All right, hello. In this video, we are covering 7.3, the ambiguous case using law of sines and cosines. This is broken up into two videos. In this one, we look at the ambiguous case, side-side angle, using law of sines. And then the second video is law of cosines. Okay, so take notes. 7.3, the ambiguous case. Okay, so this is the case where we have a side-side angle. Okay, and we said that in this case we have three possibilities, right? So when you have side-side angle, then you have these possible scenarios. You might have no triangle. You might have one triangle. You might have two triangles. Okay, so let's go ahead and take a look at this first example where we have no triangle. Okay, so the zero triangle case. Okay, so suppose that we have this here. Find angle B. Find angle B in triangle ABC. If A equals 2, B equals 6, and A equals 30 degrees. Okay. All right, so let's go ahead and draw a triangle here. All right, so A, B, and C. Let's fill this in. So A is 30 degrees. That's the only angle we know. A is 2. B is 6. Okay, so this is all we know. And so here we want to find angle B, which is right up here. I like to, normally, if we're solving a whole triangle, we would do this, right? And we see that A is 30, and then little a is 2, little b is 6, little c is unknown. Okay, so doing this to me helps me to see what I have and what which law of sines or law of cosines, which one of the two to use. So like here, if I have to solve for b, I can see that I would be using law of sines. Okay, but let's take a look and see what happens when I do that. So if I'm trying to solve for angle b, right, then I would use sine b over little b equals sine 30 over little a. Okay, and so what happens is, let's go ahead and work this out. We know sine 30 degrees is 1/2, so I don't even have to bring in my calculator just yet, right? So sine b over 6 equals to 0.5 over 2. We know sine 30 is 1/2. All right, multiply both sides by 6, and I get 6 times 0.5 divided by 2, but this becomes 3, right? And so 3 times 0.5 is 1.5. And we already know that sine can never be larger than 1, right? It's bounded between -1 and 1, right? So we already know this is not possible. So here we would get no triangle. Okay. So there is 0 triangles. Or here, they're asking you to solve for b, so you would say no solution. Okay. So I'm not sure what they're going to want you to put. If they want you to put no triangle or no solution. Okay, so just try the different answers. Okay, so let's take a look at the one triangle case. Like, how do you know if it's only one? How do you know it's not two, right? Okay, so here's the one triangle case. Okay, so suppose that you have to solve triangle ABC. If C equals 35.4 degrees, A equals 205, and C equals 314. Okay. All right, so let's go ahead and draw this. A, B, and C. All right, what do we have here? 35.4. A is 205, and C is 314. Okay. All right, so we need to solve the triangle. So we need to find all of these things here. Okay, so A is unknown, C is 35.4, A is 205, B is unknown, 314. Okay, so here I can use law of sines to solve for angle A. So let's go ahead and do that. All right, so I can do sine A over little a is sine C over little c. Okay, so this is the one I'm going to use. Okay, so sine A over 205 equals sine 35.4 degrees, make sure you're in your degree mode, over 314. Okay, and then if I work this out, I get that's A equals sine inverse of 205 times sine 35.4 all over 314. And when I punch this into my calculator, I get roughly 22.22. Okay, 22.22. How many significant digits? Okay, so 3 significant digits, so let's just use 22.2. Okay. Okay, so here, let me put all the ones that we're solving, I'll put in purple. Okay, so let me rewrite that one. That way we can keep track. So what happens is if there is a second triangle, then what happens is all the purple stuff will have two answers. Anything that's given, like here, C, A, and C, all of those that are given, there's only going to be one answer for those because we're already told A is 205, C is 35.4 degrees, C is 314. We're told that, we're given that. So there will not be another little a, little c, angle C. Okay, whatever is given, that's it. But the other things that are missing, those will have two other values if there are two triangles. Okay. All right. Okay, so we find our first angle here, right? 22.2. So if you remember when you do sine inverse, right? When you do sine inverse, it restricts your answers to from here to here, right? But we do, this is for positive and this is for negative, right? But we do know that there are infinitely many angles, right? Who when you take the sine of it, it's going to be the same. Like, for example, sine of 30 degrees, right? sine of 30 degrees, that's going to be the same as sine of 150, right? So we know that there are infinitely many possible angles where they will be equivalent. So same thing here, right? We're trying to find an angle whose sine is equal to whatever this decimal answer is in here. So we know the positive answer here, 22.2 degrees, right? We know that's this angle, right? But the other place, just like 150 and 130 and 30, right? 30 is over here, and then 150 is over here, right? Okay. So, and remember, it's because they both have the same reference angle, which is 30 degrees. 30 degrees. So just like that, here, this has a reference angle of 22.2 degrees. So the way you find your other one, if there is another triangle, is you get the angle that lands here that has the same reference angle. So the way you do that is just 180 minus whatever angle you find, right? Okay. All right. I'm going to go ahead and erase this. So if you need to go back and see all of this, just rewind. Okay. Anyway, so that's how you find the second angle A if there is going to be another angle A. Okay. So if two triangles find other angle A by subtracting this from 180. Okay. And then whatever you get, that's what you inspect to decide whether or not you have one angle A or if you have two angle A's. Okay. All right. So let's go ahead and do that. Okay. So 180 degrees minus 22.2. Okay. So 180 degrees minus 22.2, and we get 157.8 degrees. Okay. So this is my second angle A, 157.8. Now this is what you do next to determine whether or not that's possible. Okay, so check if possible. Okay, so if this is my second angle A, right? So we'll call this A2. Okay, so if A2 is 157.8, then plus my other two angles, I should get 180, right? Well, let's see. What are we given? We're given angle C is 35.4. If I put 35.4 here, right? So if I put 35.4 here, I already exceed 180, right? 157 plus 35.4 exceeds 180. There's no room for an angle B. Okay, so this here is this is more than 180. So then this is not possible. This is not possible. Having this second angle A as 157.8 degrees, this is not possible. Okay. Therefore, there is only one triangle. Okay. Hence, only one triangle. Okay. All right. So there's only one triangle. So we only need to worry about finding these other things here. So now I can find angle B. And there's only going to be one of everything. Okay. So let me do that here. Angle B is going to be 180 minus 22.2 minus 35.4. Okay. So angle B turns out to be 122.4. Okay, 122.4. And then 122.4. So then here, now you can do law of sines to find lowercase b. Okay, so let me do this. Okay, so lowercase b over sine 122.4 should equal to, I'm going to use the c's because these were given to me. If I make a mistake here, then the mistake will show up in this calculation. Okay, so you could use these a's, but you better be sure that you didn't make a mistake there. Okay, so lowercase c is 314 over sine of 35.4. Okay, and then solving for b, you get 458.10. But we have 3 significant digits, so that will be 458. Okay, so, oops, let me put that in purple. Okay, so that's how you figure out whether or not you only have one triangle or two. As soon as you find that first angle, subtract that by 180, subtract that from 180, and then check to see if you bust 180 when you do that new angle plus the others. Will you have room for the other two angles? Okay, so 157 plus 35, you bust 180. Okay, so it's not going to be possible. Okay, all right, so let's take a look at the two triangle case. All right, so this one will take a little longer because there are two. So two triangles. And so just like that last problem, when you find that first angle, you check to see if you'll be able to squeeze in the other angles to equal 180. And if you could, then a second triangle is possible. Okay. All right, so let's take a look at this one. All right, solve triangle ABC if A equals 54 centimeters, B equals 62 centimeters, and C equals, no C, A equals 40 degrees. Okay. All right. So again, I like to draw my triangle. You don't have to. I'm a visual person. All right. So we have 40 degrees here, 54 here, 62 here. And since we're, oh, well, here, I'll do this. We know it's going to be two triangles because I said I was going to do an example of two triangles, right? So let me do this. Those will be all the numbers for the first triangle. And then over here, we will have all the numbers for the second triangle. Okay. All right. We know these values up here. So let's go ahead and fill these in for both triangles. 54 here, 54 here, 62 here, 62 here, 40 degrees here, and 40 degrees here. Okay, those are going to be set, and then these will be different from each other over here. Okay. All right, so looking at this, I can find angle B. Okay, so all right, so let me do this. Angle B1. Okay, so here I'm going to do sine B over 62 equals sine 40 over 54. Okay, and when I solve for B, right, sine B equals 62 times sine 40 over 54. and then take the sine inverse. So B equals the sine inverse of 62 times sine 40. Sine 40. Ah, that looks a little messy. All right, sine 40 all over 54. Okay. And what happens is we get roughly 47.56 degrees. So this is what we get, right? Okay, so now let's go ahead. That is definitely our first angle B, 47.56. Okay, so all right, two significant digits, so 47.56, so that's 48. So this is going to be 48 degrees. Let me do that in purple. Okay, so this is going to be 48. Okay, so now we can find the other one by subtracting this one from 180. Okay, all right, so let's do this. So angle B2, we check to see if it's possible, right? So we do 180 degrees minus 47.5, 48 degrees. Okay, and what we get here is 132 degrees. Okay, and then we're going to check if possible. Check if angle B, which is 132 degrees, check if that's possible. So 132 plus angle A plus angle C. Is there room to make 180? Okay, so angle A is 40. So 132 plus 40 plus C. Is there room for it to make 180? Yeah, because we get 172, right? 172 plus C equals 180. Okay, so yes, it's possible. So we do have two triangles. So here we just found angle C. Here, angle C2. Angle C2 is 180. Here, 172 plus C equals 180. And so C equals 8. Okay, so an itty bitty degree there, but still possible. Okay, so let's go ahead and fill in our second triangle. Okay, so angle B2 is 132. Okay, right here. This is angle B2. Okay, so that is 132. And then our angle C turned out to be 8. Okay. Let's go ahead and get the angle C from over here on for triangle 1. Okay, so we're going with 48, right? Okay, so 48 plus 40, so angle C is going to be 48, 180 minus 48 and minus 40, right? So here for angle C, so here C equals 92. Okay. All right, so let's go ahead and fill that in. And then now, once you have this, all of this, now you can use law of sines over here, and you can also use law of sines over here. Since we found B, and A's are given, I would set up my law of sines using angle A and little a. Okay, that way, if you made any mistake here, it won't show up when you do your calculations for little c. All right, so let's do that. So little c. Little c. So we're looking for little c. Sine of 92 degrees equals, what is little a? Little a is 54 and then 40. 54 and sine 40. Okay, and so when we solve for c, 54 times sine 92 over sine 40. When you punch that in, we get roughly 83.96. Okay, and so that's going to be two significant digits, so that'll be, we'll go with 84. Okay, 84. So let's go up there and fill that in. Little c is 84. Okay, and let's do the same thing, but with this one, we'll set up our law of sines, sine of 8 degrees, and then sine of 40 degrees, 54. Okay, so let's go ahead and do that on this side. Okay, so little c is going to be little c over sine of 8 degrees equals 54 over sine 40. Okay, so c equals 54 times sine 8 degrees over sine 40. And when you punch that in, we get 11.69. Two significant digits, so we'll go with 12. Okay, so C2 up here will be 12. Okay, so just make sure you keep track of the two triangles. Okay, so remember, once you find your first angle, you go ahead and subtract it from 180, and that's going to be your second B. So you find your first angle, and then to see if the second one is possible, you just check to see if you bust 180. If you don't bust 180, then it's possible. Like here, 172, we didn't, we don't have 180 here. There's room for that missing angle, okay? But if we got 180 here, there's no room for that missing angle, so it wouldn't be possible, okay? That's how you know, okay? And then once you have that, you can get your third angle, and then here, finish getting your third angle, and then get your third side, But keep track of which ones go with which triangle, okay? All right, so that's it. If you have any questions about this, just email me or text me or use that function on WebAssign. Okay?